Okay, we are about to start, and we can start our last speech. I would like to do a self-introduction. I am the developer engineer of Fang technology, and also I'm a contributor of Jenkins. So I want to talk about the serverless Jenkins on Kubernetes. And actually, Jenkins has a relatively long history, and this program just was born from Hudson in 2004, and according to the statistics of Jenkins' official website, around 250,000 Jenkins services operating now, and it has around 15 million of users and over 1,000 Jenkins plugins. Jenkins has made great success in the certain areas, but also there are some challenges. First of all, Jenkins has a relatively long history. At that time, the distributed system is not popular, so they may have the single point failures problems. So the users need to update or install the plugins from time to time, so we need to restart it. And our CSD cannot operate normally, and also Jenkins is a Java-based program. Our CSD operation is usually run in the working time because we need to to change the source code. So it may just consume a large disk space and increase our cost. Also, Jenkins at the time of Jenkins, the physical resource is scarce and the users is unlike of us. If you want to start a CI/CD operation, we just create a pod for it independently. But at that time, Jenkins, if you want to possibly utilize a physical node, so it has an algorithm to try their best to use the node repeatedly, and which may lead to the slow operation of Jenkins, and also other CSD operation might influence source, and also Jenkins, the storage of Jenkins can be sequenced into the hard disk and might just consume the disk space, and we need to deal with it by ourselves. Also, Jenkins has many other problems. So Jenkins X just come to the market during this background. It was born from the GEP. Actually, it is a kind of enhancement proposals of Jenkins. So, which was originated from Jenkins, and currently the Jenkins X has already become a totally independent program. And the design concept of Jenkins X is to use the power of Kubernetes to construct and to build a modernized CSD platform. As for the modernization, I have two understanding of it. First is that it has a modern architecture, for example, to solve the problems of the great consumption of the disk space, and also as for the enhancement of the user experience, we need to provide automated CI/CD. For anyone who have done the CI/CD, we need to do a lot of work. For example, in KVX, we need to learn about the Docker file, and to use the Docker build. And Docker is not enough. Also, we need to write some of the YAML, and also we need the Helm to package. So these series of works are really painful, and also I need to manage the environment. As for Jenkins X, so the users can avoid learning these new things, and also Jenkins X can support the traditional workload as well as the cloud native workload. So in the the initial phase of the design of Jenkins, it is different with the traditional Jenkins. We will think about how to create a pipeline and how can run it and to satisfy the demand of the customers. But from the initial design of Jenkins X, they need to think about what people want and how can we design it better to cater to the perspective of the customers. So we want to have a faster time and to higher frequency of the deployment. So through the automated software delivery, so our build software and release of software can be more reliable. So Jenkins X, during the initial design, it has done many of the research. This is a accelerator book has mentioned the high performance team, some of the methods that they would use. So Jenkins X has learned these methods and put them into the design of the products. For example, we need to versionalize all the artifacts and to automate it, deploy, and also to have the development based on the main bodies. If you're interested in it, you can have a look at these books and you can learn many new things about the DevOps. So we have this graph of Jenkins. This is the original graph of the design of Jenkins. First of all, this is from the perspective of application. And in the traditional Jenkins, we all know that we are defining a freestyle job, and then we have a line. In Jenkins X, we're defining an application, and it has a line. So when you are creating the application, also it has provide the function of environment management. We can see it from the left graph. On the above side, we have the Git repositories. There are three repositories. One is the application repository, and one is the kind of the productive namespace. Jenkins X also take the environment management as one part of it, and all the applications in the environment are DevOps through the rectification of the code and through the OPS to simultaneously put into our environment. And Jenkins X also can have the function of the preview of the environment. So when we have submit a pull request, it will just produce a service address after the codification, and we can easily see the environment directly, which is more easy to be observed. And as for the working process of Jenkins X, we can briefly scan about. First of all, the developer will submit a pull request to our code repository, and it will have a preview environment, and relevant staff can review on it. And after the review, we will just put it into master. We only have one sub-branch that is based on the development of the main body. We can have a faster release of it. And when the PR is in the master and you will have a release version, this is only a small change, and this release version will simultaneously put in the stadium, and the Jenkins X will just execute the automated execution. And when the users need to go to the production, and we can put it into the production repository. And when this master is put into the master branch, it can be put into the production environment simultaneously. And Jenkins X, during its evolution process, also it has experienced many of the changes in technology. First of all, Jenkins X was born in GP, and it was using the static Jenkins server like most of us. And then we have mentioned that the static Jenkins server has some problems like the single point problem, the assumption of the disk space, and then they have introduced the Pro as a receiver of the webhook, which is a high performance and a high available architecture. So our static Jenkins server might always lose some of the information. So once we have Pro, we don't need to worry about these issues. And even though we have introduced the Pro, the webhook will not be immensely will not be released. So we have another, that is the one-shot Jenkins, actually like a Docker image. At that time, we use Kinetic View to run the Docker image and then to deliver into the Jenkins and to finally destroy it. And then in this procedure, we find that we're still using the JVM, even though we are not running it for a long time. Still, we are using the JVM, and also our loading time might be quite slow, and there are some of the performance problems. And then we have introduced Tecton, which is a very pure cloud native and Tecton. And in 2019, Jenkins X also has introduced its own standardized definition, used the YAML file. And next, I would like to introduce the technology behind the Jenkins X. First, I think the first problem we need to solve is the application package, because Jenkins is from the perspective of application. So at that time, Jenkins found a project called Draft, which is also a cloud native project. So actually, its concept is that to isolate the user's contact. And when we choose a language, it will produce a Docker file automatically. And Jenkins X will utilize this kind of thought. And we have the build packs, and there will be more files produced in the build packs. And it will, like the doc file, Helm chart, scaffold, YAML, and the series of the files, and they will automatically create repositories for them. Therefore, the users only need to finish the CI/CD. Most of the users don't need to just change this configuration. If they have higher demand, they will just have some changes of it. And once we have the lines, how to have some improvement in the architecture. So serverless Jenkins was born in this background. It mainly have the following characters. First, it just ran the lines based on the container. And also, serverless is run based on the events. So our webhook message. And also, it is a loosely coupled architecture and a highly available architecture. And also, for our webhook events, and for our underlying pipeline engine, which is a Tecton actually, which was born in a Knative published by Google, which is a serverless platform. And in serverless, one indispensable part is that we need to build a serverless container, and the Knative have the Knative build program. But once they have this program, the user wants to do more things. For example, whether we can have the unit test, and we can have the code quality test. So we have a Knative pipeline, and currently this project is split up as a top project, and it mainly targeted the cloud native underlying pipeline engine. And Jenkins X is running on this Tecton. Tecton has many good performances and characters, but most importantly, it can just eliminate the JVM. It has a fast running, and it uses the CRD plus controller. Its API is a declarative. We can just use it very easily. We can just evoke it very easily, and our CI/CD task will not fail due to some of the reasons. And after Tecton, we may have the this project. Actually, it was born on the basis of the K8s. It has many of the repositories. Every day, it will have tens of thousands of the CI/CD tasks running on the serverless platform. So many of them messages came to K8s through Pro and through other module of the CI/CD to be consumed. And also Pro can just support the chat ops, and we can have some comments to achieve, for example, or how do we allocate the task and how to shut down these kind of tasks. So Pro is just such kind of high performance and high available event reactor. So once we have this, we need to combine them.
So CRD is actually a CRD controller. It's kind of like glue between modules. And yesterday's conference speaker also mentioned that CRD plus controller has become kind of like hero of our story. So it means that we can have this kind of like loose coupling, and this will make sure that we have a quick start and we have very rich, we have a lot of like community resources, and if we have, we need to, if we want to develop a system ourselves, we need to work on high availabilities ourselves. So by using this kind of like combination of CRD and controller is much more convenient. And we also have these this kind of like pro environment, and we have a Git provider and a pro and Kubernetes API server and the JX controller. JX controller will create a watch and per job here, and when we create an object, and the Kubernetes API server will send the project creates event to JX controller. The JX controller will receive the data and create a pipeline run. In this way, you can see that all the modules they are connected and they are connected through a middleware. And the coupling is quite loose among all the components. So this is the Jenkins X, a more detailed structure. And actually we have a lot of components in this dev environment. And most important is that we have the pipeline operator in the Jenkins X. And the Jenkins X, we have a lot of tech-down. We have tech-down pipeline and the tech-down tasks. It's kind of like definition of our flow of a pipeline, and it will trigger pipeline run. And during pipeline run, we will also push temporary PR and the pod to the pod, send the pods to edge, and if the CID task is successful, and we will actually deploy it to the environment. So in this diagram, you can see the summarized structure is basically actually has been confirmed. The one issue is that, as I mentioned earlier, in Jenkins X, we do have like hardware the storage in the hard drive may run out. And we do have, or we encounter some issues in terms of the pod and the definition. They're useless, and all this data will be actually stored in the warehouse or the Kubernetes API, and Jenkins X actually has defined using Kubernetes core resources to clean the useless data. So we can actually use those to clean some of the useless data, the previous environment, and clean up the pod and clean up expired data. So JX, and we have provide this GC and to actually, and it will regularly clean those expired data. And also that when we develop these things on Kubernetes, there are actually indeed some problems in terms of the dev pod. We will automatically need to sync local code to pod, and also it is difficult for us to. So we have this new dev pod So dev pod can be kind of like a development environment for us. The dev pod actually has two main functions. It will automatically sync local code to remote pod. And if you write the code in IDE, and you just use Command S, and it will automatically sync to the remote pod, so you don't need to manually upload the data. And for the deployment, it's quite quick. And also, another thing is that the S code, I think you're all familiar with it. So it's kind of like web-based. So you can deploy directly on the web page. And Jenkins TV pod actually has integrated these functions, so you can directly edit your code on the website. And this is a demo video. So you can see that if you enter the DB pod, and it will return an address, you can open it. So we can see this familiar VS Code page, and then edit the code. And open the terminal. Enter the command to start the server. So we don't need to go through the complex procedure that we used to have. So we can directly visit it on using the web browser. So this one is actually the Jenkins X structure. So it actually includes a lot of modules. So for Jenkins X, it actually has far more functions than what is shown here. And Jenkins X actually has utilized the advantages of cloud manufacturers or providers. So for instance, when we cleanse the pod, what if we want to save all the data? Jenkins X actually has this kind of function. They will automatically sync those data to the cloud providers, and for instance, object storage or other storage. So in that way, we will have these kind of like so now let's have a look at the demo. So we have a pre-installed Jenkins X environment, and it's installed and it's saved in QKE. So I'll just please allow me to enter my catalog to have a look. So we can create create, and quickly start. And enter the name of the warehouse and click confirm. And it will ask me to select the type of language. So for instance, if it's Android or .NET, so let's go for Golang. And also initialize the warehouse and enter the information, and then it will start this warehouse establishment locally. So now it's completed, the procedure is completed, and you could actually use this command to see the pipeline build. So it's actually quick. So I may have run some of the steps in here, and let me open the GitHub page. So here is the hello KubeCon page that we just created, and it will automatically be sent to GitHub. And we can change some of the code here. Well, I'll just, because the time is limited, I'll just do a pull request. So open a new project. And change some of the code here. Okay, now we send it to the code warehouse. And a new pull request. We can click create here. So there's a webhook message has been sent and has been responded, and the user is waiting to be started. So actually I used my account to kind of like create this kind of robot. So the robot has sent the messages back to me. So for instance, if I can assign the task to myself, and then the robot will help me to do all the things, and then I can do something just random. So you could see that I'm just doing some random stuff, and the preview will give me an address, and then we can open the address and the changes that we've just made, and also the environment that we can get the application here, and we can see the project that we just created, and also the URL. So that's the end of our demo. So in the end, so this is the QKE Kubernetes QR code. We are an open source container platform, and there's a Jenkins China WeChat official account. I'm also a member of Jenkins China. If you are interested in joining our community, you can scan the QR code and join us. For further discussion, do you have any question?
Well, I want to ask, where do you run the serverless? Well, actually, just now when we are running the pipeline, we don't have a static server. So when I open my terminal, I can see some of the pods that I've run on this pod are completed and they are destroyed. In this process, we don't have a static server. We have one pro as a static server and pro create a pro job, and the CI/CD don't have a static running, and every time it creates a new pod and you check on. And just now, I think it is still based on the GitHub. If we do it, it can also have a similar result on other systems. So for our community, we are doing some of develops based on this function. Maybe currently GitHub has the best performance, and later on GitLab and the official website has a roadmap, and it supports the reports from different Git providers. I want to ask, as for Jenkins, it also has another function is that it has many plugins, and as for the Jenkins X, as for the serverless, and this cognitive, well, these plugins also be used. That's the Jenkins 2 version. One is called the next version of the CI/CD, and another is called traditional Jenkins plan, and it will run some of the Jenkins server. You can use the plugins, and you can gradually put it into the next generation of the CI/CD platform. And since our friend has mentioned whether it can cover the GitLab, it don't have a very full coverage, so many users will not use it directly. You can experience first of all. So actually these plugins are not supported on this. Yes, maybe these plugins will not be used later on. So well, let's write the plugins by itself, this kind of files. It has other extension mechanism that is different from previously. You have add-on the Prometheus issue, and if I do some of the blue and green deployment, that it is totally different with the traditional Jenkins. Well, as for demo, you have said that we don't need to codify. Actually, this codify process is we have automatically produced many files, and among these files, they have included these things that we need to codify. For example, in our Docker file. But for some of the users, especially the developers, they don't want to learn these collect Docker file on Helm chart, the definition of it. And if we have build text, if we can define build text for ourselves, and the developers don't need to write these Docker files anymore. Still, they need to have the process of the Docker build. But our current developing is more inclined to the situations that also needs to write this. Because for the microservice, it is really simple. So in it, you just need to change some code in it. You don't need to change a lot of things. Yes. But ultimately, for the users, we need to do it from the perspective of the application. Current users do need to care about Docker file and Helm chart is because they create it as quite relatively new, and it doesn't have enough top layer architecture. So we won't choose. We don't need to write .char-l. The cloud native application also be like this, our developers. They don't need to care about when we need to change, we can just change it rapidly. Thank you.